Welcome to another episode of AI Frontiers, where the latest advancements in artificial intelligence and natural language processing are explored. Today, focus is placed on 8 cutting-edge research papers, all published on May 2, 2025, within the realm of computer science, specifically computation and language. These works highlight critical themes, groundbreaking findings, and future directions for how machines interact with human language. Presented through the lens of the ArXiv preprint server Daily, this episode promises a deep dive into the forefront of AI innovation. Let's begin with an overview of computation and language, a vital subfield of computer science. This area concentrates on the interaction between machines and human language, powering technologies such as chatbots, translation tools, and voice assistants. It merges linguistics, mathematics, and engineering to drive innovation. Challenges like language understanding, generation, and fairness are central to this field. The papers discussed today showcase a range of solutions and persistent gaps, reflecting the dynamic nature of this research space. One prominent theme in these papers is temporal reasoning, which examines how machines interpret time references in text. This includes explicit mentions like yesterday, implicit cues tied to context, and vague expressions such as a long time ago. A significant contribution comes from Kenneweg and colleagues, who introduced the Traveler benchmark to test model performance across these categories. Their work reveals clear gaps in handling vague phrases, a critical issue for applications like scheduling or analyzing historical texts. Another key theme is model security and robustness, addressing the vulnerabilities of large language models to adversarial attacks. A standout study by Muhaimin and colleagues proposes a defense system combining filtering and summarization. This approach detects malicious inputs without the need for costly model retraining. Such innovations are essential for safe deployment in sensitive domains like customer service, underscoring the ongoing struggle against harmful prompts and the need for robust safeguards. Explainability and fairness form a crucial research theme, focusing on making AI decisions transparent and unbiased. Research by Dhaini and colleagues uncovers gender bias in the quality of explanations generated by models, even when trained on unbiased data. This disparity is particularly concerning in high-stakes areas like healthcare or law. Technically, post hoc explainability methods are used to analyze decisions after processing, highlighting the urgent need to ensure fairness and maintain trust in critical applications. Advancements in model architecture and learning innovations are also prominent. Studies explore optimizing structures for enhanced performance, such as the transformer search method for translation tasks by Wang and colleagues. Additionally, Ahmed and team introduce MateICL to improve in-context learning. At the core, attention mechanisms help models focus on relevant input parts. These developments pave the way for more efficient, resource-friendly AI systems, addressing practical deployment challenges. Turning to key findings, several insights stand out across these studies. Kenneweg and colleagues show that models struggle with vague temporal reasoning. Muhaimin and team achieve an impressive 98.71% success rate in blocking malicious inputs. Dhaini and colleagues highlight persistent gender bias in model explanations. Wang and team demonstrate how smarter designs significantly boost translation performance, while Ahmed and colleagues MateICL enhances focus in large contexts. These results signal major strides in language processing. Methodologically, these papers rely on several common approaches. Large language models serve as foundational tools for text-related tasks. Benchmark creation, like the Traveler dataset, ensures standardized evaluation. Probabilistic modeling addresses uncertainty in language, while genetic algorithms optimize model architectures. Attention mechanisms are adapted to tackle long context challenges. Together, these methods balance innovation with practical constraints, forming the backbone of current research in computation and language. Diving deeper, the first seminal paper by Kenneweg and colleagues from 2025 introduces the Traveler benchmark for temporal reasoning. Its objective is to test models on explicit, implicit, and vague time references using a synthetic dataset of 3,300 question-answer pairs. Findings reveal poor performance on vague and long sequence tasks, exposing a critical weakness. This publicly available benchmark offers a pathway for progress, addressing a fundamental gap in language understanding with significant potential impact. The second seminal paper, by Muhaimin and colleagues in 2025, focuses on protecting language models from adversarial attacks. Their objective is to develop an efficient defense, achieved through a filtering and summarization system to detect harmful inputs. Remarkably, it achieves a 98.71% success rate without retraining. This lightweight, practical solution enhances AI security, making it a vital contribution for safe deployment in real-world applications and a foundation for future protective mechanisms. The third seminal paper, by Dhaini and colleagues in 2025, investigates gender bias in post-hoc explainability methods. The objective is to assess disparities in explanation quality across gender subgroups, testing 5 models on unbiased datasets. Findings show persistent bias, with explanations varying in faithfulness and complexity. This raises serious fairness concerns for AI transparency, especially in critical domains, urging the integration of equity into explanation frameworks and shaping ethical AI deployment. Looking to the future, several directions emerge for computation and language research. Hybrid systems incorporating human feedback could better handle vague language. Universal security protocols are needed to counter evolving threats. Fairness must be embedded as a core design principle in AI. Cross-disciplinary collaboration, spanning linguistics to ethics, will be essential. Additionally, addressing scalability in temporal and contextual understanding remains a priority to push the boundaries of machine-language interaction. In conclusion, key takeaways from today's discussion highlight persistent gaps in temporal reasoning, as shown by Kenneweg and colleagues. Security innovations, like those from Muhaimin and team, are transformative. Fairness in explainability, as emphasized by Dhaini and colleagues, demands urgent attention. These papers are shaping how AI will interact with humanity in the future. Curiosity is encouraged. Stay tuned for more insights into the AI frontier. A note on how this synthesis was crafted. The content was developed using AI tools for efficiency and depth, with narrative structure assisted by GPT-Grok, modeled Grok 3. Text-to-speech synthesis was powered by Google for accessibility, and image generation was supported by OpenAI for visual elements. All content has been reviewed by a human expert to ensure accuracy. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from ArXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights.